On the left here, you see the Arduino side. In the lower right, you see a video of the Nano here. It's blinking. I still don't have batteries installed. Don't put batteries in this thing while the USB is plugged in because you might burn it out. Okay. Maximum charging voltage on an 18650 is 14.2 volts, and the USB provides 5 volts. So no batteries are in. Make sure that. I've also got my switch to off, so I got nothing connected. So make sure you keep that in mind, okay? So here I have, Arduino up. If you do not have the Neopixel library, you can go to Sketch, Include Library, Manage Libraries here, and I'll go through this with you. And then just type in Neo up top here one of these days. There we go. Type in Neo, and there's a ton of different options for that. Okay, so we just want regular Neopixel right here. Here's Neopixel, right? And so you get the latest version, and you hit install. Oh, I'm actually a version behind. Whoa, I'm a few versions behind. That's all right. I'll just leave mine there. All these should work, so I'm not going to mess with that now. If you don't have any Arduino installed or any Neopixel installed, make sure to install it. Okay, so once you install it, now you can go to File, Examples, and then scroll all the way down. Mine comes way down here, way out of screen, but Adafruit Neopixel and go to Strand Test. Okay, and a whole new window will pop up with the strand test. We're going to pull some stuff out of here, right? Okay, so first thing we're going to pull out is the include. So I'm going to copy this, right click, copy. Go to our new sketch here, hit enter a few times, and paste that up top. There we go. So that's going to tell Arduino to include this library. Okay, now we're going to come back here. Yeah, I'll pull the pin 6. That's fine. Put that up here. But we're going to put in our own define here. So hashtag define. And we're going to do pix. And we're going to count how many neopixels we have around our thing. So let's see, what do I have? 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 23, 28. So I have 28 neopixels on mine. Okay, so count your neopixels and put it under pix. Okay. Okay, so now we're actually going to create an object called strip. So from this Neopixel section, we're going to use the Adafruit Neopixel library to create an object called strip with these parameters to it. Okay, so copy that, paste this, but instead of saying 60, we're going to say pix. Okay, and see, these are modern Neopixels, so they run at 800 kilohertz. That's the right data order. We'll call that good. Okay. If you have some special or weird Neopixel strip where things aren't going quite right, try swapping the order or the speed. Okay. Chances are the defaults are correct for you. Okay. There's a few examples in here on different types. If you have a white Neopixel or white LED on your Neopixels, then you can use this one, etc. Okay. The little resistor, it suggests to put out on here. I don't add the capacitor. I don't know, you can if you want, but I never add the capacitor, but I do add the resistor. I've seen that help. Okay. All right. So I think that's about it here. So under setup of this, we have strip.begin and strip.show, right? So we're going to have to make sure to add that to our setup. We can just copy and paste it here, I guess. Copy under our setup and then paste. Cool. So one more thing I like to do here is I like to do a testing. So once it boots up, it sort of tests the neopixels, right? So I'm going to do some for loops. I'm a big fan of for loops. So oh yeah, a lowercase, for parentheses int a equals 0, a is less than pix, a plus plus. In the parentheses, start your bracket here. Okay, so now I'm going to hit enter, and then what I'm going to do is strip, or whoops, to capitalize that, lowercase strip dot set capital P ixel capital C color. Should turn orange if you typed it right. And then strip, or then pixel A, comma, and I'm just going to type in yellow, and I'll define that in a second, okay? So it's going to turn it yellow. So up here under my defines, I guess I'll scroll this down a little bit here. So I'm going to define yellow as, let's see, so we're RGB. So I guess I want a lot of red, a little bit of green, and 0 blue. Okay? So everywhere where I type yellow in my program, it's going to get rid of it and replace it with this. So even though this says yellow here, it's actually going to put this in here. Okay? That's what this define thing does. So everywhere I typed in pin with capitals, it actually replaces it with 6. So in here, it says pin, but the define function, before it compiles, gets rid of everywhere it says pin and replaces it with 6. So really easy to manage your variables up here like that. So strip.setPixelColor a comma yellow, right? Easy. Which is going to set it to a lot of red, a little bit of green, which should be yellow. I don't know. We'll see. It's easy to change here, right? So it's going to set that, but it's not actually going to show it, right? Now, as we know from Neopixels, you have to tell it when you want it to update. So right after it tells pixel A to turn yellow, we have to do a strip.show, right? And that's going to pulse the data that's in memory to the Neopixels. All right? And then we're going to wait for a second. We'll use the delay because we're lazy and this program's simple. So delay, and we'll do, I don't know, 35 milliseconds. Okay? And then we're going to turn that pixel off. Strip.setPixelColor a comma, I'll do off. And off means red's at 0, green's at 0, and blue's at 0, right? So I want to copy yellow, but instead of being yellow, we're going to be off. So that's 0, comma 0, comma 0, right? So we just turn that pixel off, okay? And then it's going to keep going through this. Now the last one it goes through, it's going to turn on that. So it's going to turn it off, right? So let's start with the logic here. So it's going to start with a equals 0, right? And it's going to test it, right? It's going to keep repeating this loop while a is less than pix. Well, pix is 28. So 0 is less than 28. And it's not going to do this yet till we're at the end. Okay, so now it's going to set pixel color, the pixel number, which is a, which is at 0 right now, and turn that yellow in memory, right? In Arduino memory. Then it's going to push that data to the Neopixels, right? So the Neopixel will now turn yellow. It's going to wait 35 milliseconds. And then in memory only, it's going to turn 0 or A off, right? And then it's going to go to the end. It's going to increment A up 1. So now A equals 1. Oh, whoops, that's not a 0. That's an O. There we go. So now A equals 1, which is still less than pix, right? Pix is still 28. And so it's going to do the same thing. Turn 1 yellow. Now, still, even though we're at this point, it shows the first Neopixel, which is Neopixel 0, as yellow, right? In memory, it's turned off, though. And now in memory, the one after it's turned on. Okay, that's a little tough to follow, maybe. But when we set pixel color, we're setting it in memory. when we're telling it to show, we're pushing that data to the Neopixel strip itself. Okay, so set pixel color a comma yellow, which is now 1, and then it says a strip.show. So what it's going to do is broadcast the data of 0 being off and 1 being on, right? So the second Neopixel, Neopixel 1, is now on. Okay, with the first one being off, and it's going to continue that. So 1's off, 2's on, 2's off, 3's on, right? So it's going to keep going like that, and it's going to do that for all the pixels. But on the last one, once pix equals 27, it's going to turn 27 yellow, which turns 26 off, right? It's going to do a dot show, and then it's going to equal 28, which it won't actually turn that last one off. So afterwards, we have to do a strip.show to make sure it turns off that last Neopixel, because that's not included in the for strip. There's only one dot show, and that's to update the next one that's on. Because there's not a next one turning on the last pixel, we're going to have to update it out here. Anyways, that was a long bit. Hopefully you understood this. So now that I got that set up, what I'm going to do here is go to Tools. I guess I should probably choose the Arduino board. This is a Nano. Okay, the board is a 328p. I don't know if it's an old bootloader. We'll try the regular one. And port, probably 32. We'll see. And here I hit upload, and we'll see if it does anything here. So currently compiling sketch. Okay. Got a lot of libraries on here, so it might take a second. But yeah, all we're going to do here is a little test piece. And just to see if the Neopixels light up in the lower right. And it's uploading. Well, it says it's uploading, which I don't think it is, because we're just blinking. So, yep, not responding. Okay, well, so it's not on that com. So what I'm going to do here is I'm going to observe the comms 25, 26, 27, 1, 3, 31, 32. Okay, so I'm going to unplug this Arduino here. And I'm going to look at the port. It looks like it was 32. Okay, so it might be the old bootloader. Okay, so just plugged it back in. Tools, port, back to COM32. Cool. Okay. So at Mega 328p, old bootloader. Hit upload. Should compile a lot faster this time. Uploading. Oh, there it goes. It's flashing right. Okay. Oh, there it is. Cool. So in case you guys didn't see it, look in the lower right. I'm going to push the reset button, and we can watch the yellow flash around. Perfect. Okay. And that looks like a pretty good yellow. I'm going to look at that again. Yeah, that's a decent yellow. Okay, I'm liking that yellow. Okay, so we know these things work, right? Let's see. So we got everything set up. Now what do we do? So we have to make a couple things here. Okay. So I'm going to do program and speed. That's going to be my two variables. When I push these buttons here, it's going to change programs and speed. Okay. So I'm going to make an integer called PGM. Oh, semicolon. All right. Integer SPD semicolon. Okay. I'm going to get this out of the way. All right. So see, what do we do here? If oh, I guess we should. Yeah, what should we do? We should have an int pixel, so you keep track of any pixels we're playing with, and int brightness, which is just bright here. Okay. And what else should we be playing with? So which pixel we're playing with, which brightness we're playing with. We'll call that good for now. Okay. That's plenty of things to play with in here. Okay, so if we'll make like 3 programs and then play with the speed in a second here. So if PGM equals 0, right? Don't do a single equals. We got to test if it equals. We can't set it to equal 0. So if PGM equals 0, start our bracket. See, what are we doing? So let's do the old strip is off, or the old pixel is off, and the new pixel off. So it's a lot like our test program, our boot up program. So strip dot set pixel color, capital C, capital P. There. Okay, turned orange. That's good. Okay, and so let's go with pixel here. So pixel, comma, yellow. Okay, so it's going to set that. Enter. Oh, space, space. Oh, I guess I should do that on the next line here. There we go. That's a little more human here. A little easier to read. Okay, next thing. I'm going to put a bunch of spaces here so it's not so high up. Okay. So next part, like the other one, we got to show it, right? Strip.show. Okay. And then we'll worry about delays later, okay? And so next thing it's going to do is strip.setPixelColor. Oh, sorry. Let's see, I got this wrong here. So the first one, let's see, get rid of that. We're going to copy and paste this here. Okay. And then put something in the middle. So, assuming we had something in the last piece, right? So we got to turn the last one off. So the last one that was turned on is off now, right? And then we got to do pixel plus plus, okay? And to make sure it doesn't go over the amount of pixels we have, we're going to do a modulo equals pix. That way, if it ever equals 28, right? Because our pix up here is 28, right? Pixel modulo 28 equals 1 remainder 0. So that means it's going to set it back to 0 here. So if a pixel ever equals 28, it's going to go back to 0. Okay? So it can go to 027 and stop here. Okay, so that's our first program, right? So if we don't touch any buttons, it'll just run this program, right? And that's it. Okay, next program. So if PGM equals 1, enter this time, right? Okay. Now, let's do a flashing. Like everything just flashes on and off really fast. So instead of just going around in circles here, it's just everything's gonna flash, flash, flash. Okay. So that will be for int a equals 0. A is less than pix. There we go. Less than pix. And a plus plus. Okay. So what we're gonna do here is strip dot set pixel color turned orange. We're good here. A comma yellow. Okay. So, and then let that end. Okay, so if we do that, it's just going to turn them all on. Okay, so not quite what we're looking for. We don't want them just all on, right? We want them to turn on or off. So we're going to have to change this a little bit, right? So we'll use that bright variable. So if bright, so that means it's going to check bright. If bright doesn't equal 0, it's going to do this. Okay, put this whole thing in brackets, right? Okay, copy this, paste it. So if not bright, there we go. And we're going to turn these off. So if bright doesn't equal 0, it's going to turn them all yellow. Okay, if bright does equal 0, it's going to turn them all off. Okay, and then we're going to do a, whoa, whoops, hit my keyboard there. Okay, so we're going to do a strip.show. And then we're going to do bright equals not bright. So if bright doesn't equal 0, it'll equal 0 now. If it does equal 0, it's going to equal 1. It's going to change it to 1. Okay? So bright equals not bright. All right. So that means every time this program runs, once it hits this, it's going to see what bright is. If bright is equals 1 or more, it's going to turn everything yellow and show it, right? If bright equals 0, it's going to turn all the pixels off and show it. And then it's going to swap them. So that way next time it runs, it'll do the opposite. Okay. Next thing we're going to do, going to do one more program. If PGM equals to, let's think of a good program here. So let's do some red and blue, some police action here. Right? Not necessarily, well, if it's on your car, it's not legal. If it's not on your car, I guess it's legal. I don't know how legal it is. But we're going to turn half them red or half them blue, okay? So first thing we got to do is turn them all off, right? So if, oh, sorry. So I'm going to copy from the first one here. Oh, I guess I didn't put this in a bracket. Sorry. So it sets them all to a color, right? Get rid of this one. Okay. So back up here. So for every pixel, it's going to turn them all yellow or off, right? Depending on what bright equals. Then it's going to show them. Then it's going to make them opposite, okay? My bad. That would have looked kind of funny. It would have probably worked. Well, every other one would have turned on, I guess. That's funny. Huh. Yeah, put your bracket there. My bad. Okay. We're back to writing this. So program 2, we're doing police style, right? So I'm going to copy this part. But this time, they're all just going to be set to off. Okay? So now they're all on, or they're all off, right? Okay. So now, actually, yeah, I guess we could make it red-blue. I was going to have it half left, or left side red, and then right side blue. But, yeah, why not just make it red and blue? Okay, so sorry here. I know you're watching me, like, come up with it, but I'm literally... I'll delete this, too. Okay. I'm literally going to copy everything in here and paste it in here. Okay, so our second program now, instead of yellow and off, it's going to go blue or red, right? So our order here is RGB. So A comma R, which is 255, G 0, and B is 0. Okay, or else it's going to do, let's see, so RGB, right? So 0 for R, 0 for G, and full or 255 for B. All right. So it's just going to flash. So it's going to start off flashing with the yellow going around, right? And then it's going to go to the whole thing flashing on and off. And then it's going to go to flashing red and blue, right? Okay. So now that it tests the program, now we need to wait for the buttons. Okay. So what we're going to do here is put 2 more variables in here. And I don't know if you mess with millis much, but we're just going to watch buttons while we wait. Okay. So long unsigned. Let's see, timer equals millis. And if you remember, millis pulls the amount of time that the Arduino has been running in milliseconds, right? So down here, we're going to do a while statement. While millis, all right, got to do parentheses because it's a function that returns the value of how long it's been running in milliseconds. While millis is less than timer, do this. Okay. So first of all, we have this variable called speed, right? Let's see, where's our speed? There it is, SPD. Okay. So if SPD equals I guess we should do that in a different spot. I'll show you where to do that in just a second here. Okay. So, oh, that's right. We want that one. Okay. So if we press a button, right? So what would that be? Oh, we got to set up buttons in here too. So under our strip.show, or sorry, under our setup here, you have to set up some buttons. So I'm going to put some space for those. pinMode. So what do we put on? We put them on 8 and 9, right? 8, comma, input underscore pull up. Okay. So it's going to pull it high with this little resistor. And same thing on pin 9. Going to internally pull it high with the little resistor. So if you hit it, it's going to be pulled low. So to detect a button press, if not digital read 8. So it's going to read what pin 8 is, right? And if it's a 1, it's going to switch it to 0. So it's going to be untrue and not come through. If it's grounded out, it's going to flip it, turn it to a true, and then it's going to execute everything in these brackets. So if that's pushed down, hit enter. See, I guess we'll do PGM++. Okay. And then PGM percent equals 3 modulo equals 3. Okay. And that's it here. Okay. Then we do speed. Okay. So I guess we could copy this actually. Make it easy on ourselves. Okay. So if we push button 9, which will control the speed here, it's going to take the speed And we'll do a bigger increment than this. So SPD equals, I guess we'll do, I don't know. We'll do 30 no, we'll do 25 millisecond. So speed plus equals 25 every time it comes through here. Okay. And if SPD is greater than, I don't know, 150, then SPD comes all the way down to 10. Okay. And then that curly, and we're good here. Okay. So, let's see, we got, I guess it starts at, I guess it should start it at 10 then. And speed equals 10 to start with. And I'll go 35, 60, 85, 110, 135, and then come back down to 10. Okay. So we got, what is that, 6 options? Cool. Okay. So after this here, after it's waiting for us to push stuff and do stuff here, we should probably tell it to wait till we let the button go also. Okay. So it's going to do this here. We're going to give it some debounce also, and we're going to do that with delay. Delay 2. Okay, I guess I should probably spell delay right. Delay is 2. Okay. Let's see. So while not digital read 8. So while you're still holding that button down, do nothing. All right, so start curly bracket and curly bracket. Enter, and then debounce the release, and the program's good to go. Okay. Gonna do the same thing for this right here. Okay, Control V. Gonna debounce pin 9 this time though. Okay. So as we push the button, it's gonna do this, right? And until we let it go, it's just gonna stop here. So if we're holding a button, the program will just stop. I'm not gonna go into deeper into how to keep it going while it's doing this. I have to create extra variables for that. But for this, it really doesn't matter. It's a simple program. It's not going to be doing much. We're not asking much of it. Okay. So while millis is less than timer, you can adjust things in here, right? Okay. And now, once we leave this, we have to increment this up, okay? So now, over here, we're going to do timer plus equals SPD, semicolon. All right. So what's going to happen, let's say we start at 10 milliseconds, right? So let's say millis starts at 100, okay? So timer now equals 100. There's been 100 milliseconds since this thing's been booted. Okay, it's going to go through this, and timer right now equals 100, okay? So by the time it gets over here, millis probably equals 101, right? So it's not going to do any of this here, all right? So what it's going to do here is it's going to skip it. It's going to skip it immediately, okay? Because timer is 100, millis is 101. It's not less than it. So it's going to skip all this and then hit this part. Timer plus equals speed. So now timer equals 110, right? So it goes back over here and it runs all this stuff again, okay? So timer is 110 and millis is probably maybe about 102. Now it's going to keep testing it, right? So now millis is 102. It's running the lights, right? Flashing whatever program. And it's going to run this for 8 more milliseconds, right? And so it's going to wait for you to press buttons. Okay? So if you change the speed, if you change the program, it'll change those, right? And once that's done, it's going to leave it again and re-increment the timer. and then run all this stuff again. So I guess let's give it a test here. I'm going to upload this. Oh, of course. Of course I forgot semicolons. Very me. What do we got here? So digital read 9. So if, yeah, okay, that's right. Double bracket starts the bracket, ends there. Okay. So, oh, okay, here we go. So if that's all good, so you got to get speed equals 10, semicolon. Okay, so I got an extra parentheses in there. Sure. Okay. Okay. Let's give that a try. Getting further down the program anyways. Oh, got something else here. Okay. Expected some semicolons somewhere. Oh. That is supposed to be a semicolon, not a comma. Okay, I think did I copy and paste that a few times? No. Okay. Am I sure? Yep, there it is. Okay, I copied and pasted that. So I'll fix both those. Okay. Let's see what happens. Oh, it's uploading. All right. Let's see what we got going on here. So that's going pretty fast, right? I'm going to hit this button, and it's going slower. Going a little slower. Going really slow. All right. Going really slow. Going very slow. Then this one should speed it up. There it goes. Okay. Now I hit this button. Whoops. Oh. Okay. Oh, I see. That was way too fast. Okay. Slow it down a little bit here. And then I hit this button. Whoa. Have to hit it once. There we go. Wow, that is a bright flash. Okay. Hit this button again. And that is supposed to be red and blue going back and forth, but I got to slow that down a little bit. Wow, that is really bright. That should work fine for emergencies. Okay. So there's how I wrote the program. I'll just have this available for you. Hopefully you understood it. So if you want to add a new program to it, right? First thing you got to do down here is up this. So make sure it can go to program 4 now, right? And then if PGM equals 4, then, write whatever in there. And it's just going to, increment every time it'll increment along the timer here. Okay? So if you want to add different speeds or whatever, or up the increments, change those around, you can too. But there we go. That's me writing a program for a hazard flasher for my car. And let's see. No, not change that. Let's go to not that one. There we go. I think that's our winner right there. That's the one I'll be using mostly. If anything happens, just set this on the ground, let it flash. Anyways, thanks for watching, guys. Next video, we'll be putting it all together.